Hello everyone, my name is Mihir Takkar and I'm today bringing you another interesting course from Heroku, which is Introduction to Programming with C. This is a practical hands-on course where you will not only learn the fundamentals of C programming language, but also get a glimpse into how computers work behind the scenes. In this course, we'll start off with some basic syntax of the C programming language, and towards the end, we'll build some cool projects as well. Throughout this course, we'll be completing a lot of practice examples and quizzes, and I would highly recommend that you first give your 100% and try to solve these programming quizzes before you move forward and jump into the solution. Also, some of you are definitely going to ask me which programming language should they start off with first, whether they should learn C, Python, JavaScript, or something else. So, my take on this is, even though the other languages that I mentioned, such as Python, are really beginner friendly and very easy to understand, but they also hide a lot of complexity on what happens behind the scenes when you run a computer program. In the world of software, we call this abstraction. But with C programming, you will get a better sense of the inner workings of the programming language. And that's why we have chosen C. And once you get a knack of the basics, it perfectly makes sense to move on to Python or JavaScript and make more complex projects. If you haven't programmed before, don't worry. I will walk you through each and every step that you will need to get started on this exciting journey. So let's begin. I'll be going over how you can set up your Windows computer to run C and C++ programs. And to compile our C programs, we'll use perhaps one of the most well-known C compilers, which is the GNU C compiler. The Windows package of GCC is called as Minimalistic GNU compiler or MinGW. Let's go ahead and download MinGW. Let's run it. So this is some standard stuff over here. I recommend that you don't change the installation path unless you have a very strong reason to do so. Let's say continue. Over here, we only need the MinGW C compiler, which is the MinGW base. And just to be future proof, let's also download C++ compiler. So click over here and say mark for installation. Next, go to the top over here where it says installation and say apply changes, and it might take some time to download and install these compilers. Alright, so once this is done, let's go to our C drive and check if we have installed our compiler over there. And indeed, we see a new folder. Let's go inside this C drive MinGW folder. And let's go inside this bin folder. So this is the place where our GCC and G++ exe files are located. So usually we don't have to come to this folder and run the compiler from here, but instead what we would like to do is be able to run these compilers from any other folder that we are working in. So let's see if we are able to do that. Let's go to our command prompt window and let's type in GCC and press enter. So it looks like we are getting an error over here. What happened? We thought that we just installed it there, right? Well, we know that our compiler is located at C drive MinGW bin folder, but our rest of the system doesn't know that. So how do you tell our computer the location of the exe files for the compilers? So to do that, we'll use something called as a path variable. So let's go and search for the environment variables of our system. And here is the path variable of our system. So whenever you run a command in a command prompt window, the first thing it does, it looks for that executable name in the current directory where you are in. If it can't find that exe file over there, then it looks through all the paths which are mentioned in this path variable over here. Let's copy our C drive MinGW bin path and add it to this list of path variable and say okay, apply. Now be sure that you close your command window and open it again. Now try GCC again and you should see something like this. Even though it looks like an error, all it is saying is we haven't provided the C program that we want to compile, and that is fine. But at least now we know that C compiler is installed on our system and we are able to run it. So this is the file where I have written my C program. So let me just go ahead and open this in Sublime Text. So what we see over here is our first C program. And don't worry if you don't understand everything, because in the next class we'll go over each line in detail. But today I want to show you how a compiler converts this human readable program to something that our computer can understand. So next I'll open my command window and change the directory using the cd command to go to this folder where I have stored my file. So now we are in this directory. Next, the name of our C compiler is GCC. So I'm going to say GCC. Let's give the name of our file, which is hello.c, and a bunch of flags. And let's name the output file as hello. So I'm going to say -o hello. Let's press enter and run this command. So as you see over here, we have produced the output file, which is hello.exe in this folder. Let's go ahead and execute this exe file, and there it is. It says, hello, I'm your computer and I can do things that you can't. So let's start writing our first C program. I'm gonna say, this is my first C program. So in C, when you start a line with 2 slashes, the compiler will ignore anything after that. And these are called comments. So it is always good to add some comments to your code, so that when you look at the same code after 1 year, or let's say if someone else is looking at your code, they can understand it as well. So now we are going to say hash include stdio.h. In C, the lines which starts with the hash or the pound sign are special. So these are not the instructions for your machine, but these are the instructions for your compiler. And what we are telling the compiler over here is take this file stdio.h and paste it over here. Stdio is the standard IO. IO is input and output. And it has the functions like the printf and the scanf that we are going to see further. So the next thing that we want to do is write our actual program, and that we do inside the main function. So we are going to say int main and then brackets, and then we are going to have a pair of curly brackets. So C is one of those languages which uses curly brackets to group things together. So essentially what we are saying to compiler is everything that is within these curly brackets is part of the main function. Makes sense, right? So just like we saw before, let's print something out to the screen. And if you remember, the name of the function was something called as printf. So let's say something like I have %d number of apples, and then we're gonna say 8. So what we are telling the compiler to do is take whatever number is over here and put it inside this sentence, the place where we have this %d, which means an integer. And because we said that this is an int main, which means we are gonna return an integer, and as we promised, let's return an integer to the operating system. So you could return any number from here, and it's up to the operating system to decide what to do with it. But the normal convention is to return a 0 for a successful execution, or 1 or even higher numbers to indicate some failure. So now let's run this and see if it works. So let's try to compile this, and to do that we'll say GCC, which is the name of our compiler. We'll say -wall. Now I'm not gonna tell you what that means. I want you to look that up on internet and find out for yourself. Remember, one of the goals of this course is to make you a good problem solver, and to do that you need to have some research skills as well. So I want you to think like a scientist and not just take whatever I say. So go to the internet and find out why am I using dash wall, and maybe you can share that with your other friends in the comments below. And then we'll have the name of the file, which is hello.c, and then we'll say the name of the output by using dash o. The name of the output file we want is hello. So that compiles without any error. Let's try to run this, and you can run it by using /hello. There it is. It says I have 8 number of apples. But this is a boring program, right? I mean, there isn't much useful that we can do with it. What if the number of apples that I have change every day? What if someone gives me new apples? So instead of directly printing it out over here, let's create an integer which will store the number of apples that we have, and then we'll print that out. So what should we call it? Let's call it num apples. Int num apples is 8. Now instead of writing 8 over here directly, I could say num apples. So this is similar to what we did in the machine code, right? When we had to put a number inside a memory, and this is what we are doing over here as well. So let's see if this works. So we are gonna compile it again, and then we are gonna run it. So as you see, we got the same result, but this time instead we are storing this number in a memory somewhere. So let's do more interesting stuff with our program. So let's say if someone took one of the apples that I had. So let's see how we can say that to our program. So should we say something like int num apples equals to int num apples minus 1. So let's see if that works, right? So we'll compile the program once again. Oops, what does it say? It says redefinition of num apples. So it is telling us that you have already told me what num apples is. It's an integer. So now every time you want to use num apples, don't give me the int once again, right? So what we should have done instead is just say num apples equals to num apples minus 1. Now let's see if that works. We'll save it, and then let's see if that works. We didn't get any red flags, so that's a good sign. Let's see if that works correctly. And there it is. It says I have 7 number of apples, which is what you would expect if I had 8 and someone took 1 away from me. So this is good, but still not that interesting, right? What if we want the users to tell us how many apples they have and then print it out on screen? So let's try doing that. So we'll first get rid of this line which we had over here. So instead of saying int num apples equals to 8, we'll just say int num apples, because we don't know how many apples the user has. So let's first ask the user to tell us how many apples do you have, and then we are gonna say scanf. So printf is used to print to the screen, but a scanf can take the user input and store it in our program. So we are gonna say scan an integer for us, right, and store it in num apples. So now let's see if this works. We're just gonna clear our screen. Then we're gonna say compile it once again. So we did get a few warnings, but let's leave that for now as it is. So there were no errors. So it's asking us how many apples do you have. So let's say I say 10, and gives us something called a segmentation fault. So whenever you get a segmentation fault, remember that your computer is trying to tell you that you are either reading or writing from a memory location which you are not allowed to. And it makes sense for the operating system to do that, right? What if your program was modifying something in someone else's program's memory? I mean, it would be a chaos, and that's why it can't allow you to do that. So what went wrong? So let's see if our warnings can give us some hint. So in the first warning over here, it is telling us that something is wrong with num apples in the scanf line, right? So what we want this line to do is to take the user input and put it at a location which we are calling num apples. But do we actually know what num apples is equal to right now? We don't know, right? It could be any garbage value that the compiler chooses to come up with. So let's say if num apples had the value xyz in it, what's happening right now is the computer is trying to write to the location XYZ instead of the num apples, which is actually the value of num apples right now. And this might be a little bit confusing to you right now, but you will get a knack of it once we go ahead. So instead of saying num apples over here, what we want the compiler to do is actually store at the address of num apples. And the way you call address in C program is to write an ampersand. So we say scanf, take the user input and put it at the address which we are calling it as num apples. So let's see if that works. So we compile it once again and let's run it. How many apples do you have? Let's say 20. And there it is. It says I have 20 apples. So in the previous video, we did a few basic operations with printf and scanf statements. So now let's take this one step further and try to make our program more interactive. So what if we want our program to tell the users if they have more than certain number of apples, we want to tell them that they have too many apples and maybe they should give them away. Or if they have less than certain number of apples, they can keep it. The way we check for conditions in C language is by using something called as an if-else statement. So let's see how you could write them. You would say if num apples, let's say we want to compare it with 5 number of apples. So we'll say if num apples is greater than 5, we'll add a pair of curly brackets. We want to say printf, you have too many apples. Else, so if the user has less than 5 number of apples, we want to say printf, you have a few apples. And notice we added a tab over here. I mean, if we want, we could have everything in just one line and it would still work fine. The only reason to have a tab over here is to make it more readable. As we said in our previous videos, you are not just writing this program for yourself, but for others to read it as well. So you should make every effort to make it as readable as you can. So let's try to compile and run this and let's see if this works. So we'll say GCC, so it compiles without any errors. Let's run it. How many apples do you have? Let's say I say 10. Now it does say you have too many apples. The only thing I don't like is we should have added a new line character over here. So with that, you know enough of C language to do our first quiz. And your task is to create the game Who Wants to Be a Millionaire? So essentially, we want you to create a quiz. We want you to have at least 4 questions. Each of the questions will have at least 4 options. If the user gives you a right answer, you should give him +1 point and -1 point for wrong answers. And in the end, your program should print out the user's final score. So this is how I would go about writing this program. First, you set up your template and you do all the regular stuff that you do. You include the stdio.h file and then we welcome our user to the game. Next, let's go ahead and write our first question. So we'll say printf, who is the president of the United States? Then let's give users 4 options. And now we want to wait for the users to give us their input. And as we saw in our previous videos, the way you would take input from the user is by using the scanf statement. So in the previous videos, we have seen that to scan an integer, we use a %d. So we want to scan if the user is typing in option A, B, C or D. So what should we write over here to scan your character? Well, in this course, I'm not always going to tell you what you should be using. And in such situations, your best friend is going to be Google. So if I were you, I would go to Google and say %d. So I would say C language first. Say %d is integer. Let's see what we get. This concept seems to be called format specifiers. So the percentile is the format specifiers. The percentile specifiers that you can use in C are %C for character, %d for integer, and so on. And what we want is to scan a character. So we'll use the percentile C. So let's go back to our program. We'll say percentile C. So we don't have a location to store the answer. So let's go ahead and write a location where we'll store our answers. So what should its type be? The way you define characters in C language is by using the keyword char. So you would say char, let's say user selection, and we'll store the user's answer at address of user selection, right? So as soon as I reach this point, if I were you, I would first print it out to the screen and see if I have done this part correctly before moving ahead. So let's just print this user selection out. So let's say user selected percentile C user selection, right? So let's first clear the screen. Then we'll say, let's compile this. I mean, there is an error. So we need to say printf. So now let's try that again. It compiles without any errors. So it means that we are okay. Let's try to run this. So the first two print statements went correctly. Next, it's asking us to give an input. Let's say if we said A, it says user selected A. So I think our program is doing fine until here. Let's go back to our program. We don't need this statement. We were just checking if we are correct until here. Now we want to check if the answer was correct. So we'll say if user selection is equal to A. Now note, I'm using two equal to signs over here. In C, or in fact in most programming languages, a single equal to will assign the value to a variable, whereas a double equal to sign, you are doing a comparison. So this is a common mistake most students make while initially learning C language, is that they use a single equal to sign while comparing things. So if the answer was correct, we wanted the user score to be 1, but we haven't defined any variable to store the final score, right? So let's go ahead and say int final score. So let's start the final score from 0. Final score equals to final score plus 1, right? Or if the user didn't give a correct answer, we want to say else final score is equals to final score minus 1, right? So let's see if we got this part correctly. So we'll say printf user score is, we'll say percentile D because it's an integer, and final score. Let's clear the screen. Let's compile it. It compiled without any errors. So let's go ahead and run this. Let's say if we say A, which is the right answer, and it gives us user score is 1. So that was correct. Let's run it again and let's see if we give a wrong answer, what happens. And user score is minus 1 because 0 minus 1 will be minus 1, right? So that's correct. And just like you did for one question, you would repeat these statements for 3 more questions to get a quiz which is made up of 4 questions. So I hope you enjoyed doing that quiz, and we'll be doing more such fun programs in coming videos. So in the program that we just saw, I also want to walk you through a few terms and concepts which might help you to gain a further understanding of how programming languages work in general. So when we said we wanted to have a variable called user selection, which is of type character, so this is called declaring a variable, because we are telling our computer the name of the variable and what type it is. But in this line itself, our compiler also reserves a space in the computer memory for us, depending on the type of the variable. And hence, this is not just declaration, but also its definition. Note that at this step, we don't know what's the value inside this space. So it could be any random value. But for this guy, we are not just declaring and defining it, we are also initializing it. And thus this line has both the declaration definition as well as the initialization. So my question to you is, within this program, can you see another declaration and definition? Well, if you said that we declared and defined our main function over here, you got it correct. Note that over here we are not only saying to a computer that the name of the function is main and it will return an integer, but also we are telling the computer what operation it's gonna perform and what exactly goes inside it. And thus this is not only a declaration but a definition as well. So my next challenge for you is, can you solve a definite integral using your C program? So we have a curve over here which is defined by the equation y is equal to x square plus 1. So it will look something like this. And I want you to find the area under this curve between x equals to 0 and x equals to 3. So if it was a circle or a rectangle, you could calculate the area they occupy using the formulas that we know. But for a shape such as this one, how do you do that? And to give you a hint, what one could do is divide this entire region into smaller rectangles and then calculate the area of each one of them and add them up. But as you see in this drawing, it will be still a kind of an approximation because there are these regions over here which we do not account for. But if you use your imagination, you would notice that as you go on decreasing the width of this rectangle, your error will also start reducing. Your calculations will become more accurate. Or in mathematical terms, as your width approaches 0, your error will tend to 0 as well. So with that understanding, can you write a C program which can calculate the area under this curve, that is its integral, between x equals to 0 to 3? Before we start writing a program to do this, let's think of all the variables that we might need to do this program. So first of all, we'll need a place to store the x coordinates and the y coordinates of the curve. For these x and y values, we can't just have 1, 2 and 3. We need a lot of rectangles over here. So we need a lot of intermediate points, and thus we can't use an integer over there. We want a data type that can store decimal values, and the data type that can help us do that is called as a float. So we'll say float x and y. Next we'll store the width of this rectangle. So we'll say float width. We'll need a place to store these upper limits and lower limit. So we could either have our program hard coded with the upper limit and the lower limit, but if you were smart, you would rather take them from the user. And at last, you also need a place to store the area that we are calculating. And to get a good precision, we'll use a float over here as well. So with that understanding, let's go ahead and write our program. So first we set up the template as we always do. Next, let's go ahead and write the variables that we just decided to use. So we'll say float x, y. Note when I say this, I'm saying that both x and y are of type float, and this is a convenient way of defining multiple variables of the same type in a single line. Then we said that we'll need a place to store the width of the rectangle, so we'll say float rect width. Then we need a float for storing the area that we need to calculate. Next, let's just go ahead and ask the user to input the upper and lower limits. So we'll say printf enter the upper and lower limit, and then we'll need a scanf, and because both of these are integers, we'll say %d space %d and then store it at address of upper limit and lower limit. Next, we want to go over the x coordinates and y coordinates of this entire curve, and to do that we need a loop. In our last example, you have already seen how to use a while loop, and you could use the same over here as well. But let me show you another type of loop which is more suitable in this case. And the way you write it is, you would say for, we want to start the x from the lower limit. So we will say for x is equal to lower limit, then you add a semicolon. From x is equal to lower limit until what? We want this to go on until x is less than or equal to the upper limit, right? And in every iteration of this loop, what do we want to do? We want to increment the x coordinate by a small value, which is the width of our rectangle. So we'll say x is equal to x plus rect width. We haven't initialized our rectangle width over here. So let's just go ahead and initialize it with a small value. So we'll say float rect width is equal to 0.01. We'll see the effect of changing the rectangle width on our answer. But that should be good for now. And in this entire loop, what do we want to do? The first thing that we want to do in this loop is to get the y for the given x. And we already know that for every point on this curve, y is equal to x squared plus 1, right? And now that we have the x and the y, what will be the area of this rectangle? It will be length times width. And in this case, our length is the height of the rectangle, which is y. And our width is the variable which we have called as rectangle width. So let's go ahead and write that. So we'll say area is equal to y times rectangle width, right? And for every iteration of the loop, we want the area that we calculate to be added with the previous area that we calculated for the previous rectangle. So we could simply say the current area is equal to area plus what we just calculated. And to make sure that we get the initial area correctly, let's initialize our area with 0. And once you are done with this loop, let's just say printf area under this curve is %f because it's a float, and we'll say area, right? So let's try to compile and run this and see what happens. So we'll say gcc integration.c, and we come across an error. So it says invalid operands float and float. It looks like we are doing something wrong on this line, and my doubt is we are not squaring this properly. So just like we always do, let's go to our friend Google and find out what's the correct way of squaring a number in C. So we'll go to Google. So we'll say C language, square a number, and let's go to the very first result, and we see some interesting things. It says use the power function in C to find the power of a given number, and to do this, math.h header file is now supported in C language. So it also gives us an example. So we are definitely doing it the wrong way. We need to do something like this. So let's go to our program and do that. So we'll include the header file math.h, and then instead of saying x square like this, we'll say POW x comma 2. Now let's see if that works. So it compiles without any error. That's a good sign. Let's go ahead and run this. So it's saying enter upper limit and lower limit. So we'll say 0 to 3, and it says area under the curve is 0.00. What's going wrong? So let's try to troubleshoot this. We'll try to add a print statement within our loop and print everything out. So let's try to print everything out. So we'll say printf. Let's try to print the x. This is of type float. Then the y. This is of type float as well. And the area. So let's go ahead and run this. 0 to 3. So what happened? We wrote a print statement, but nothing came out. So it looks like we are never entering the loop, and that's why whatever area was here is directly getting printed over here, right? So in what cases will we never enter the loop, right? We have interchanged the upper limit and lower limit, which is not intuitive. So we should have rather said and lower limit and upper limit. So that was a silly mistake that we made. So let's try to do it again. So let's try to compile this again, run it 0 to 3, and there it is. Now we got inside the loop, and we also got the area under the curve is 12.05. And you can try this out mathematically. The correct answer for this should be 12. And as you see over here, we still get some error, which is 12.05. So let's try to go ahead and reduce the width of our rectangles and see if we get more precise answer if we do that. So let's say instead of saying just 0.01, what if we said 0.0001? Now that should increase our accuracy significantly. Let's try that. 0 to 3. And as you see, we have reduced the error significantly. So instead of 12.05, now we are getting 12.007. So let's see, what do we have next? Our task is to find sum of all natural numbers until 11. So think about it. How will we write a program that can do this? So before we start writing the actual program, let's first think about the variables that we might need. So to go over all the numbers, we'll need a place to store that number.
So we'll need at least an integer which will store the number that we are currently working on. Next, we'll also need a place to store the result that we got. So let's call it sum. So essentially, we'll need to start from the number 1 because it's our first natural number. Then go to 2, add these both, store it at our location sum, and then go to 3, add the sum that we got previously to this 3, and store it again at the same place, which we have called as sum, and so on until we reach 11. And some of you might know that this could also be done using a formula, but for now, let's stick to the old-fashioned way of doing it. So with that understanding, now let's try to write the code for that. So we said that we'll start with a number. So we'll say int number, and we know that we want to start with the number 1 first. So let's even initialize it and say int number equals to 1. Then we want a place to store our sum, and we want our sum to start from 0. So let's say int sum is equal to 0. So now how do we go over all these numbers? So until now we have only seen how to check conditions in C. I haven't told you how you can go through different types of things in C. And to go over things in any programming language, we need something called as a loop. And there can be different types of loops. But in this example, we are going to use one of the most basic loops, which is called as a while loop. And let me show you how to write that. So you would say while, and then we need to write our condition. While until what? We want to say while number is less than equal to 11. And just like we did for the if statement, we wrote the condition in the round brackets. We'll do the same over here as well. And while the number is less than 11, what do you want to do? We want to say sum is equal to sum plus number. So this line will add whatever our previous sum was, which right now is 0, and add it to our current number. And once we have got the sum, next we want to say now increment the number. So we will say number equals to number plus 1. Essentially, if we have got our logic right, this loop will continue until we reach the number 11 and then come out of it. So once you have come out of the loop, what do you want to do? We want to display the sum that we have got, right? So we'll say printf. We want to say the sum is, let's say, and the sum is going to be an integer. So we'll say %d sum, right? So let's see if this works. So we'll compile it. We have called it loop.c, and now let's run that. So here it is. It says the sum is 66, and you can verify that was the correct answer. So in the program that you just wrote, I want you to try something out. So what happens if a user enters a really large number for something such as 999999999, and let's see what we get as an answer. Oops, there's something wrong there, right? The sum can't be 0. Can you find out what's going wrong there? And remember, whenever you write a program which takes a user input, you always want to check your program for corner cases such as these. One of the most important things that you will do as a software engineer or a computer scientist is to look for these corner cases. You need to be able to find out cases where your program fails. And trust me, history is filled with examples on how things could go wrong when a programmer like you didn't take care of situations like these and bad things have happened. So let's see what's really going on over here. So we are taking the user input, which in this case is a really large number, and storing it at a place which we are calling it the user input, which is of type integer. So there must be something wrong going on over here. And to understand what's going on, we really need to dig in and see what's happening behind the scenes. So when we run our program and the computer sees that we need a variable called user input, which is of type integer, on most systems, it will reserve 4 bytes of memory location for the user input. And thus, we do not have an infinite space to store the numbers that we want. So now let's try to determine what is the maximum number that we can store when we say the user input is of type integer. So let's try to figure this out on a number line. So with the 32 bits that we have, and given that we want to store both the negative integers and the positive integers, overall we'll have 2 raised to 32 number of integers that we can accommodate. And if we want to have equal number of both of them, we'll divide this number by 2. We'll get 2 raised to 31 negative integers and 2 raised to 31 positive integers. And given that we also want to store 0 over there, let's subtract 1 from the positive side. Thus, on a system which uses 32 bits to represent an integer, the maximum negative integer will be minus 2 raised to 31, and on the positive side it will be 2 raised to 31 minus 1. And with that, now you should have a good idea on why when we entered a large number, things were going wrong. So when our user said 999999, what happened is this number overflowed from the 4 bytes that the computer had previously reserved for it. So just like if you have a small bucket and if you pour too much water into it, it will overflow, right? That's what's happening over here as well. But why did we get 0 over there? Well, when an overflow occurs, the behavior of the system is not predictable. In fact, it might be completely different on your computer. And by the way, this concept we just learned is also called as overflow for obvious reasons, right? So now you know why that was happening. But we still don't know how to get rid of it. And just to clarify, the overflow that we just saw, I said that it might be occurring with just user input. But if you observe in the program, even the sum can have significantly large values. So the overflow could happen to any of these variables. What you could do is, instead of defining them as an integer, you could say double. So with a double, your computer will reserve more memory space for you. And let's also go ahead and change these format specifiers to something called as a long float. So let's see if that works. We'll compile it. Let's try to run it. So let's input a large number, but not so large that we'll have to wait hours for our program to execute.
Alright guys, that's it for the first part of this course. If you would like me to continue working on this series and publish a next part, do let me know in the comments. Also, if you learned something new today, please do share our channel with your friends and subscribe to our channel because that is what will keep us going. It was a pleasure teaching you. I'll see you next time. Till then, stay tuned. Goodbye.